This video discusses the User Preferences menu, which is found under the Utilities menu. If you've been following along at this time, you can enter into User Preferences. What this menu does is it gives you options to set the Powermaster for more specific applications that you may wish to perform. The first section we have at the very top is called Error Limits. We have meter test error limits, CT test error limits, and PT test error limits available. What this allows you to do is give a buffer before a fail signal arises on your test. For meter test error limits, we recommend left at the default of 1 times meter specification. That means if you have a 0.2% accurate meter, 1 time specification means that 0.2% is your pass or fail point. CT test error limits comes defaulted to 3 times specification accuracy. And the reason for this is CTs are accurate at their rated load, at their burden level, with a sinusoidal waveform, and their correct temperature. In the fields, you have burden added into the system, you have harmonics, you have switching loads, you have temperature, all that play effect in the accuracy of a CT. CTs are rated typically 0.3%, but that is only at 100% of rated load. So in a 100 to 5 CT at 100 amps, you can expect 0.3% accuracy. However, from 10% of rated load up to 99% of rated load, their accuracy is 0.6%. Below 10% of rated load, there is no stated accuracy for CTs. Leaving a specification accuracy of 3 times gives you at 100% a 0.9, or below 100% a 1.8% accuracy rating. Combine that with the 0.2% accuracy rating of the meter, and you're still approximately within 2% accurate for your site, which is something a lot of utilities shoot for, is 2% site accuracy. Below the test error limits, there's additional data that can be saved: meter trend data, waveforms, and significant harmonics. The meter trend data will basically, during your test, trend your voltage, your current, your power, your frequency, and it will return an RMS plot of said values. Waveforms, it takes a snapshot of your waveforms, and harmonics, it records harmonics that are set to record based on the settings below. You may wish to do this if you're at a site where you're having problems getting your meter to test and you're curious if the meter is capable of accurately metering that site that it is installed in. If they are unchecked, it will not record them. To the right, we have demand test options. These allow you to set basic demand test options for your demand testing. You can set your test limits for 3 minutes, 5 minutes, or 15. And you can set it to view your sum, your average, or your energy. The next field, maximum to save, this is your harmonic limits. You can save up to the 20th with a minimum threshold of 0.01% THD. This allows you to save up to your 20th harmonic and anything that is greater than 0.01% THD. The larger you make the threshold, the less data you will save. The smaller you make the threshold, the more data you will save. So it's up to you to determine what setting you wish to use. As you can see at the bottom now, we now have function menus available. So we'll go to F2 for next page. The next page is a measurement setup. This shows how the Powermaster performs its measurements when taking data in the field. It has 3 options: the time domain, fundamental, or FFT based. Time domain is an RMS value based on 1 cycle of a waveform, or 0.0167 milliseconds. FFT based is a fast Fourier transform over 2048 points of a waveform, which returns your values including all harmonics. The fundamental is a subset of the Fourier transform, returns just a fundamental value of the voltage or the current without harmonics included, just an RMS value. You can set all your fields to either time domain, fundamental, or FFT based all at once by pressing F3, F4, or F5, or using your drop-down menu, you can select which values you wish to record in which mode. Typically, everything is set in FFT based for the greatest accuracy measurements. The next page is a few little odds and ends that allows you to have a default pulse output for the Powermaster, and this will allow you to output a pulse to verify a counting device or to test accumulators. General settings, English is the only language that is defaulted in here. Pause after each test for user acceptance. This allows you to verify, save, or modify each step of the test process. If this isn't checked, it steps through the test instantaneously, and you do not have the option to review anything until the test is finished. Enabling audio feedback allows you to hear the beeps and whistles. General volume, meter beat volume are both just settings to change volume control. Stabilize low box phases requires your low box to stabilize before it begins to output voltage. For phantom load testing, meter warm-up time is defaulted to 60 seconds, and this is based on if you're testing an electromechanical meter which needed a certain amount of warm-up time before it began to acquire data before it was accurate. And the calibration warm-up is for our lab use. CTs, you have the options to display the parallelogram in either absolute data or relative to zero burden. Default is absolute data, which allows a more accurate rendering of the test results. The IEEE accuracy parallelogram can be viewed either by itself, which would be the 0.3 and 0.6% accuracies, your settings, which would be, if you use the default 3 times, 0.9 and 1.8, or you can view both of them, which is what most people choose to do. So you have 4 parallelograms defining your CT test results. And if you do not wish to ever see a CT pass or fail, the option beside of it, Enable Pass Fail, you can uncheck that and you will no longer see a pass-fail message on your test results. The next page has custom fields for test sessions. This allows you to create custom fields to acquire data which we may not have included that you would manually enter during the testing. This data could be anything such as GPS coordinates, kilowatts found, kilowatts left, temperature, humidity. It's your decision on what you wish to use these fields for. The next page is user preferences for load box codes. Load box codes, you have 5 default ones for the ANSI test points, plus a couple of extras. It is recommended you do not modify or change these names. However, you do have the option to create several of your own, and you could create load box codes for things such as reverse power, forward power, your phase angles, whatever you wish to design in your load box settings, you can create custom codes for it here. This is done by either entering a new row and then merely filling in the information here with whatever you wish to do with your data entry, either the alphanumeric keyboard or a USB keyboard. The next page is custom fields for site description. This would be including such things as any variable that you wish to add to it, any piece of data in your system that we do not have a field for. You can now create one of those as well for the site description. The 10th and final page allows you to swap between ANSI or IEC mode, and based on your preferences you can also change your phase difference, I leading V to V leading I. You can go from 60 to 50 Hertz. Vector diagram placement can go from horizontal to vertical. Your percent accuracy can be displayed as percent registration or plus or minus percent error. Burden class as ohms or volt amps. Meter pulse constants K sub T or impulses per kilowatt hour. Nameplate ratio can be changed 5 or 1. And then in addition to that, we also have the register test error limits and phase coloring. It is also recommended you do not change the phase coloring, as it could cause confusion on tech support calls. that is all for the user preferences. Once you've made your changes, you would push save. If you did not make any changes or you do not wish to save, previous will take you back out and gives you the option, did you want to discard and exit. Previous once again brings you back to the main menu, where we will go into sites in the next video.